Okay, I'll try. Easier, no. Okay, laws of exponents. So here are some simple laws of exponents. Okay, so let's start with the basics, okay? X to the 0. What is x to the 0? 1. Anything to the 0 power is 1. What about something to the negative power?
You have to make it to a fraction.
So it's 1 over x to the
n.
The positive nth power, right? Okay, so for example, okay, these are rules, right? So for example, 3 to the 0 equals 1. For example, 3 to the negative 4 equals 1 over 3/4, which is 1 over 3 times 3 is 9. 9 times 9 is 81. Okay? Hey, what if it's already a fraction?
Oh, then you you distribute the exponent and then you put that. Or do you?
Okay, there's very many different ways to do it, but you can actually go ahead and say this is. Okay, let me show you two ways. This is really 1 over 1/3 to the 4th power, right? Right? And 1/3 to the 4th power is 1 over 81, right? But what's 1 over 81? It's just 81, because you would copy, change, flip. Okay? By the way, do you guys know this side note about fractions? On a side note, if you have 1 over a over b, what is that? That means the reciprocal of a over b, which is
B over A.
b over a. Did you guys know that?
No. Yeah.
You need to know that.
Oh my gosh.
Well, think about it. What is 1 over 3? Never mind. That's just going to confuse you. Okay? Get it? All right? So so again, 1/3 to the negative 4 power is 1 over 1/3 to the 4th power, but we know that 1/3 to the 4th power is 1 over 81, so it's 81. So couldn't I have just gotten here if I realized that actually, you guys, you know how there's a negative exponent here, and usually that means you bring it down to under the denominator? The same thing, that is the same thing as just flipping this, taking the reciprocal of 1/3.
Mrs. Palacios, where are you?
So what is the reciprocal of 1/3? 3 over 1 to the positive 4th power, which is 3 to the 4th, which is 81. You like that? Let's try another example then. On your whiteboards, why don't you guys show me what is 2/3 to the negative 2 power.
Why do you find the y value?
Do that on your whiteboard.
Why do you find the y value for this one? I thought we're supposed to find x.
Okay, but we want to know when this equals 0, right?
Yeah.
This equals 0, when this equals 0,
And
or that equals 0.
yeah.
But what happens when this equals 0? Well, we can't solve for x. Well, we can't solve for x.
Can't you find the it wouldn't
You
be
can do the
plus or
same
minus?
thing.
Oh.
X squared. Yeah, it's plus or minus.
It's 2y, right?
Yeah, 2y, so x equals plus or minus the square root of 2y. Okay, same thing. Whether you do it like this or this is the same thing. But what do you do with that information to find out what that x value is? Take this one or this one. But you're trying to find x, so that's why you take this one and you plug it back into the original equation.
But isn't this what x is?
Okay, x is that, but what is x? But we don't know what y is. So then plug that into here to get the y, and then plug that back in. Or you could just plug this straight into the x and then solve it.
Oh,
Okay, did you guys do it?
Yeah.
Okay, so this should be the same thing as 3/2 to the positive 2 power, which is 9/4. Okay, did you guys get 9/4?
Yeah.
All right, good. Okay, so you guys got the negative exponent rule down?
Yes.
All right.
Here goes my example.
Okay, we'll do more in a minute. I'm just kind of going through the rules. What if the exponent is already on the denominator and it's negative? Then it gets to go up, right? So it's going to be x to the n over 1, but that's just x to the n, right? That's a rule. All right. What about the radical one? I mean the fractional exponent. Okay, so this one is when the exponent is what? Exponent is 0. This is when the exponent is negative. Okay, these guys. This is when the exponent is fraction. When the exponent is a fraction, like x to the a over b. Okay, what does that mean? Yes.
Isn't the a?
Okay.
It's a, and then you do the square root, right or no?
Oh, okay. Yep. Before you get there, I could break that up into it's x to the a power, right? Times 1 over b. Okay? Or we can say it's x, oops. Scratch that.
And then b goes inside. Okay.
Or it's x to the 1 over b times a. Okay? You know what? Before we even do that, let's start with simple. More simple. Okay? Hold that thought. What about just x to the 1 over n? Okay? What does that mean? We know what x to the n means. It means x times x times x times x n times. But what about x to the 1 over n? That's right. It's x, it's the nth root of x, right?
That's what I said.
How do you say, that's what you said, yeah, it's the nth root. Whether it's square root, cubed root, fourth root, right? So, for example, if I have 4 to the 1/2 power, what does that mean? That means the square root of 4, which is 2. What is the 8 to the 1/3? It's the cubed root of 8, which means what, when you multiply it by itself 3 times, what number taken to the 3rd power gives you 8, which is 2, because 8 is 2 times 2 times 2. The 3 of them can come out of the house, so it's 2. Yeah? Let's do just for fun. What is 16 to the 1/3? That the 1/3 means what? The cubed root of 16. But is there any number that you have to multiply by itself 3 times to get to 16? No, but 16 is what times what times what? 2 times
8.
2 times 2 times 2. So how many triples of 2 can you take out?
1.
So then you're going to have 2 on the outside, but 1 cubed root of 2 is still left in there. Okay?
That's simple form.
Yeah. Okay? Just like we do with square roots. But in square roots, 2 can come out of the house. But now cubed root is a group of 3 that the triplets can come out. Not the twins, but the triplets. Hey, let's just, for even more fun and action, let's make it negative 1/3.
It's gonna be a fraction.
What do we do with the negative first? You got to do 1 over 16 to the positive 1/3 power, right? So what's that? Cubed root of 16, right? And we know that the cubed root of 16 is 2 cubed root, like that, right? We don't like to have square roots in the bottom, but we're not going to deal with that right now, okay? How about this? 1 over 32 to the negative 1/2. Try it on your whiteboard.
We'll have to flip that.
Mm-hmm. Oh, you have to find your packet in it.
Where is it?
It's in that pile. Yes? Yes. What do you guys think? What should I deal with first? The negative. What does that negative exponent make me want to do to that fraction? You could do that, Giselle, but remember the trick that I taught you with this one? What did we do with this one? We just took the reciprocal, right? So what's the reciprocal of 1 over 32? 32 over 1, or just 32. So now it's 32 to the positive 1/2 power. Why is it positive now? Because we did the reciprocal of 1 over 32. And what does 1/2 exponent mean? Square root of 32. But what are the factors of 32? 32 is 2 times 2 times 2 times 2 times 2. I don't know. So I get one pair of 2's out, another pair of 2's out, right? So how many 2's can come out?
4.
2. So we have 4 rad 2. Okay? You guys feel good about that?
Can we do another one like that?
Yeah.
Another one? Okay. 8 over 9 to the negative 1/2. Then what? Than last year or than that midterm? I hope so. It all depends on you. I don't know. Do you think so? I bet.
So it's 9/8. 2/4.
And then can you rationalize the denominator?
Oh, I know it.
What did you guys do first? Okay.
Yeah, you multiply by square root.
It's not quite right.
You do this.
The square root of 8 is not 4.
I didn't have calculus buddies in this class. We are.
Just look at this will be alright, and then you multiply by
Let's wait
square
for
root to both sides. When you do that, square root times these two is going to be square root 4.
Oh, there's another calculus buddy.
2 times 2 is 4. Oh, okay, so you multiply by that.
The number that seems
Yeah.
kind of harder than it.
Okay, should we explain? You guys ready to explain?
Yeah.
So what did that next negative exponent do?
It flips it.
It flips the fraction to 9 over 8.
No, I'm good.
9 over 8 to the 1/2 power is the square root of 9 over the square root of 8. Square root of 9 is 3. Square root of 8, though, 8 is 4 times 2. So square root of 4 is 2, but then there's one square root of 2 that
So
stays
2
in the
root
house.
2?
So yeah, now you have 3 over 2 root 2. You can leave it like that, but sometimes I'll ask you, or if I tell you to simplify it all the way and we don't like to have radicals in the denominator, we have to rationalize the denominator. How do you do that? By multiplying by 1. Because isn't this 1?
Yeah.
But it's a special kind of 1. It's rad 2 over 2. Rad 2 over rad 2. Why do I multiply it by that?
Because rad 2 times rad 2 is 2.
Because rad 2 times rad 2 will give you
Rad 4 and
2.
and the square root of 4.
And so you're going to have 3 rad 2 over 4 on the bottom. Okay?
Because you don't like a radical in our denominator?
So these two are the same thing, but one is in a sense better because this one has no radical in the denominator. I need you to give me some space. All right, is that cool, guys? All right, so now that we did the nth root, what if not only is it 1 over n, but this exponent has a numerator and a denominator? Okay, well, on a side note, okay, here's a side note. If I have 2/3, do you guys agree that that's 2 times 1/3? You guys agree with me on that? Yeah? And, or can you say it's also 1/3 of 2? Yeah? We're doing the same thing here. So a over b is really a times 1 over b. Yeah? Or 1 over b times a. You agree?
Right.
Okay. So if we do that, what do we say 1 over b means? The bth root of this, right? You remember that from down here? So that means the bth root of x to the a. Does that make sense?
Can you explain it one more time?
Yes. Okay. Do you agree that a over b is the same thing as a times 1 over b? Yeah? And I'm allowed to just split up those exponents like that, right? Because when you see this, what are you supposed to do? You're supposed to multiply the exponents. And a over times 1 over b is a over b, right? Okay, but what does it mean to do 1 over b? Well, what does it mean to do 1 over n as an exponent? It's the nth root, right? So 1 over b is the bth root, right? So if that is the bth root of what's inside, x to the a, and here's x to the a.
So you basically move the numerator with the x?
Yeah. I kept it in there. Okay? What if I did it this way? This means do this one first. What's x to the 1 over b? If I do the inside first, x to the 1 over b, where's my pink? Can you give me a yellow highlighter, please? X to the 1 over b is what? No, what's x to the 1 over b? It's the bth root of x, right? Yeah? But then I have to do what to that? That whole thing, I have to do the a power. So these two are the same thing. Yeah. Okay?
Here, I'll move my stuff.
Yeah.
It's in the front. All right, questions on this? So let's practice that. Some examples. Okay, let's do that right here. Okay. What if I have 16 to the 3/4 power? 16 to the 3/4 power.
Are we starting the retakes tomorrow?
Monday. 16 to the 3/4 power.
What are we doing tomorrow? Notes?
In class?
Yeah.
Just more reviewing our retakes and.
I mean, he was here today in the morning. I know it's active baby.
Is that?
He just walks in the middle of the video. I'm recording, so
Sorry.
just chill out. Okay? All right. So, what are you guys thinking?
Fourth root 16 over 2 power 3.
Yeah, so you have two options here because remember the rule gave us two options. I could do 16 cubed to the 1/4 power, or I could do 16 to the 1/4 power cubed, right? Which one do you think is easier to work with? Doing 16 times 16 times 16, or doing the 4th root of 16?
4th root of 16.
How come? Because 16 is a perfect
Square.
4th,
Okay.
right? Because what does this mean? Okay, so let's go with the bottom option. I mean, we could do the top option too, but I think you can recognize if you do a few practice problems that this is easier. Okay? Well, this is the fourth root of 16 to the third power. What's the fourth root of 16? Okay, if you're talking, please go outside and take your conversation outside, okay? Because we're recording here and I'm trying to talk. Okay, so what times itself 4 times gives you 16? 2. 2 times 2 times 2 times 2 is 16. So that means it's 2 cubed, which is 2 times 2 times 2, which is 8. Okay? Let me show you, if you had decided to do the long way, that's okay. But this is what you would have had to do. If you took the other route and you did 16 cubed to the 1/4, that means you would do 16 times 16 times 16 to the 1/4. And if you're working harder, not smarter, then you would literally sit there on your test and start doing 16 times 16 and then times 16 again, which is not smart, right? But if you're doing the 1/4 root of that, what does that mean? Well, first of all, when you guys have exponents and the inside is multiply, what can you do to that exponent? You could distribute, right? So it's a 16 to the 1/4 times 16 to the 1/4 times 16 to the 1/4, right? And we decided what is the fourth root of 16? And the fourth root of 16? And the fourth root of 16? So then you get 8 again. So that's the other way. But don't you guys think the original way was faster?
Yeah.
Okay. Let's try a different one. What about, by the way, all of these examples were in your Thanksgiving packet. When you guys were doing your Thanksgiving packet, did you guys actually read all the note sections?
Yes.
Good.
I think for that one, in the packet it said 1/8. Because that one, you put that one on the test too, right?
There is one that's 1/8. We'll talk about that. Number 18. We'll talk about, but that's it because it was negative 3/4. Yeah. So you guys do memorize the answers. Okay. So what is 4 to the 2/3 power? 4 to the 2/3 power. Do this on your whiteboards.
What?
4 to the 2/3 power. No, that's 4 to the 6th.
Isn't the
2/3, not 2 times 3.
this is
No, it's just, you just walked into a law of exponents session.
Oh.
He's like from yesterday.
Cool.
This is factoring? Does it look like factoring?
No.
Okay, just making sure. Okay. Do you guys think this one would be easier to do 4 squared first or 4 to the cube root first? Because there's no perfect cubed root of 4, right? So this is one where I'd rather do this first and then cubed root it, huh? Right? So what's 4 squared? Is it 8? No, it's 16, right?
Which way is easier?
It depends. The other way was easier the first time, but this time, so you have to gain some experience to realize, look, if you did it the other way, you would have to do 4 to the 1/3 squared. But is there a cubed root of 4? Anyway. Okay. Then what? What is this 16 to the 1/3 business? Cubed root of 16. Well, 16 is what?
That would be
2 times 2 times 2 times 2. We did this earlier.
2.
Is that a perfect cube? No. What is a perfect cube? This 8 right here, huh? So that's going to be 2 on the outside and a cubed root of 2 still on the inside, which is very much like the problem that was on the test. Oh, so are you going to do anything? What are you waiting for me? Oh, that's what you're waiting for. Well, you want to start on the problems while you're waiting for me?
Sure.
Differentiation. Odds. The answers are in the back. Or in that, yeah. Okay, you guys get that? Okay, so far those are the 5 rules, okay? Do you think you can remember these 5 rules? Or is this one of these things where like you leave this room and all of a sudden you forget it everything? Does it make sense to you? How about you turn to your partner right now and like take turns one at a time teaching the rules, explaining the rules, okay?
Maybe I like a worksheet.
Yes. That was Thanksgiving packet. You want more? Or you want to just do them again? You want more or you want to just do them again? Okay, explain to your partner.
It starts at 136.
I don't know, it's differentiation chapter. Yeah.
That we just did. First one, 0 to 5 0. Second one, x to negative n, put it over 1. And then you move it to the denominator, or put it 1 over x.
Something else.
And that one, you move it to the power. What's 0 to the power of 0? Fourth one.
That's a good question.
Oh, I asked that.
I'm undecided.
Don't you basically put like
I think it's 1.
Code and explosion, is that right?
Yeah. Pretty much.
x over a, right?
I like how you're thinking though.
The fourth one is b, you know how it's like this?
Are you explaining to your partner?
Yeah.
Talk to yourself.
Here. Oh, yeah.
That's how you do, right? Yep. And the third one.
All the rules, like when you multiply an
Third
exponent
one
times
is
0,
1.
it's gonna be 1.
Yeah.
When you have a negative exponent, you put it under. If you have a negative as a denominator, you move it to denominator to numerator. When you have a fraction as an exponent, then you put the top one, the numerator, the fraction.
Swear, I thought it was the
Square it with the, yeah, and you put the denominator.
Well, there's 2
over
options.
1 outside.
Yeah. But then if you put the denominator back in the 1.
And then for fifth,
Good.
when you have 1, is it always gonna be 1?
That's just a simple one, basic. Yeah, this is the same thing, it's just that where A is 1, right?
Right. So if you have 1, A is 1, then you just take out the denominator, put it in the tail of the square root, and put the base.
It's all about that base.
In the square root. Yeah, and that's called the amplitude. Got it?
Okay, guys. I think you're done explaining, yeah? Let's try to go backwards, okay? What if I asked you to go backwards and tell me what... By the way, all of this is something you could have done at home by yourself during Thanksgiving. This is how I would study if I were you. Because what I'm doing to you is just reading to you what's in this Thanksgiving packet. So even if I'm not there, you could have done this on your own. Obviously, you have to like hide the answers and then, oh yeah, I get it, or oh no, why, and then go back and figure it out. But this is how you study, okay? So what is that? Can you put that into an exponential expression?
Yeah.
Okay, so why don't you do all of these? I want you to do this one, this one, ooh, and that one. Okay, put those into...
You notice or no? You notice or no?
Nah, I mean, I did. Long time. Like,
Last year around the same time.
I was struggling around this year.
No?
Oh, that.
Just this?
Hey, man.
What did the last one? It's like a note.
Math is a too genius type of subject, to be honest.
Yeah. Like, people
It
that
has to be the 1/2, remember?
good on
Negative
SAT.
1/2. Yep.
Stay in this game. Stay in this game.
Miss Han, is this one right?
Just not.
Yes.
No, sorry.
Okay, so what's the first one? What's the first one, guys? X to the
X to the
1/5.
fifth power.
1/5. Okay, what is this one? X to the
Negative 3?
-3, right? Bring it to the top.
-3.
Oh, yeah, I mean, never mind. This one is X to the
2 over 3.
3
Good.
over 2.
No, 2 over 3. Because this is a cubed root, right?
Yeah.
And what about this one?
It's x times
What's the square root of of x? X to the
negative 1/2.
positive 1/2 on the denominator, but if you don't want it to be in the denominator, it'll be? You guys see that?
How? Oh, y'all.
Josh, right
Brought
there.
the 2 out of nowhere.
Yeah, relax.
This 2 because this is a square root.
Yeah,
When there's
it's
nothing in the
1/2
front, it's
equals
implied that it's
1/2
2.
equals- I thought I knew it.
Yep.
Now I don't
Okay,
know
you
it.
feel good? I feel good. Ba-da-da-da. Okay, yeah?
And then to put it back up, the negative, take away the 1. Shoot.
Okay.
All logical. All explainable.
All explainable. That's how math is. It's not random. Never think that it's random. Just kind of massage it and do some random things and then hopefully the answer pops out. No.
That's what I hope
Okay?
every time.
It never happens. By the way, can I just tell you something? If I want to write, this is really just like not related. If I want to write x plus 1 over x minus 1, can I write it like this? Is that the same thing?
No.
Yeah, no.
Yeah,
Yes.
it is. Yeah, it is.
It's exactly the same.
When you write it in your calculator, that's how it shows up.
That's not true. That's very much not so. Okay. Because remember I told you whenever you see this, you're implying that this is grouped together
Yes.
and this is grouped together. So you have to add these and then subtract those and then divide at the end. But according to PEMDAS, if you just do it like on a straight line like this, what happens first? The adding, dividing, or subtracting? The dividing. So you're implying that this happens first. So what you're really saying when you do this, you're really saying x plus 1 over x minus 1. Is that what you meant?
No.
No.
Bro.
Okay? You guys see that? Don't make that mistake. Some people lost points on this recent test because they made that mistake. Okay? Okay, you guys, those are the integral and rational exponents, but there's more rules to exponents, okay? So before we mix it all up, I'm just going to go through the rest of the rules with you guys, okay? Also from your Thanksgiving packet. You know what I realized? I gave you guys a lot of food, but the problem wasn't that you didn't have enough food. The problem was you guys don't know how to eat. Okay? That was the problem. Okay? Oh, it's okay. Okay, so there's more laws. Okay? Laws of exponents. Part 2. Okay? Alright. What is x to the a times x to the b?
That is TBH x times a times b.
X.
I mean, like for
A plus B.
exponents, yeah.
X to the a plus b.
Oh.
Do you guys know why?
Yes.
Why?
You add the exponent.
Why do you add the exponents though?
When you're multiplying.
It's the same base, no?
When you're multiplying.
It is the same base.
Multiply.
When you are multiplying.
Oh, see?
No.
In response to
It
violence.
sees you.
Wait, okay, there you go. Okay, that is weird. Okay, let's try an example to help us understand. X cubed times x to the 4th. Is that x to the 12th?
No.
No. But it says multiply right here.
But it's the same base.
Okay, same base. What is x to the cube? Or x cubed? It's x times x times x, is it not?
Yes.
Yeah.
What is x to the 4th?
X times x times x times x.
Should I start distributing?
No.
No, there's no couch potato or whatever your sister said. Okay, this how many x is this? X times x times x times x times x times x times x, right? So that's really how many x's do we have?
We have 7.
So what did we do with those exponents?
Add
We added them. That's the first rule. Okay? What about x to the a over x to the b?
I am gonna say
X
you said
equals x a minus b.
Okay, this only works if the bases are the same. You can't do it if the bases are different. So it's going to be a minus b. Do we see, no, well, do we see why though? What if you have x to the 10th over x to the 4th? What does x to the 10th mean? X over x. Now it's ninja battle time. What happens to x over x?
Cancels out.
Well, it becomes a 1.
So cancel out.
Is there anything left on the bottom?
No.
What's left on the top? There used to be 10 of them, but 4 of them got canceled out, so now there's 6 of them, which is what you get when you do 10 minus 4. Okay? Is that cool?
Yeah.
Alright. By the way, can I do this? Can I go like this?
Two.
Oh no. Let's go like this, okay? Can I go? Oh, that's 2, and oh, that's 2. So it's 2. No, that's a red flag. Okay, they have to have the same base. Okay.
Okay, but you're just solving separately.
Okay, you can't do that. What would you do?
You would do the exponent first.
You would do the exponent first, and you just have 1, 2 down here. So then do I start going like this? No, you use it just once. So what's 4 divided by 2? 2. So now you have 2 times 4 times 4, which is 8 times 4, which is 32. Okay? So that rule only applies to the same base. Okay?
Like where's this rule?
Do it again.
This rule
It was a
wasn't on
multiple, so it
Thanksgiving.
canceled out.
It totally was. Which rule? This one?
This rule?
This rule?
No. Yes.
Oh my goodness.
No, that one.
What? This?
Yes.
This is not a rule.
So why'd you do it?
Because so you don't make mistakes.
Okay.
4 cubed, you know what 4 cubed is.
Yeah.
4 times 4. What do you mean?
Cause you gave us
I didn't
different
tell you how to walk
bases.
out the door. I didn't say,
You
ooh,
gave
left
us
foot first, right foot first, but you know that.
Different bases. That's what you're trying to like
Yes.
show us.
Basically, I'm showing you that
Yeah.
the rule only applies when the bases are the same.
Yeah.
If the bases are the same, then whatever you did before that, you learn this rule, still applies.
Exactly.
4 cubed is 4 times 4 times 4.
Unless you have to solve it. Cool.
I don't know what you mean by solve, but yeah, you just have to evaluate.
Okay.
Yeah. Okay. Okay. Like the weird one?
Yeah.
Oh, this is just, yeah, sure. Okay. Let's do 14. Straight from here. Are you guys hot?
Yes, I am.
No, let's try the air. Just a little bit. Just a little bit.
It's like, why are you tripping on that?
Stop it. Take out the base.
I'm about to do this right now.
Right there.
Well, let me just, yeah.
Hey.
I can let me hit this.
Hey.
Let me hit this right.
So then, here we go. So here we go.
Okay, I have no time to do all this. Bye.
Wait, you can't cancel anything out.
Yes, I can.
You can't cancel the 4 and the 7. They don't have any shoe combinations.
The 14, the 7.
Oh, that's a 14.
Yeah, it's a 14.
Tequita.
Tequita.
No. I can't say that.
Oh. Wow. I got it. This can't go.
Yeah.
No, can't be.
Right?
Yeah? Okay.
Because look, if you subtract it,
There's really nothing here.
this is what I got.
And
Let's see.
if this becomes
You got
3,
what?
this is out. And then
that,
this
okay.
becomes a 5.
We'll see.
Yeah.
As one answer.
That's
Not
one answer.
even.
That's one answer. Come on.
One answer.
Because if you subtract it, the 2 minus 5 is
This is not negative though. Oh, you're right. So then this goes up here. 2 x over 1
because
5.
look,
Two. Look, two. Look.
When you write it,
You write it out. If you write it out.
I got
Yeah, because it's fine.
Come on, I'm not crazy.
That's not it.
How was it not?
Don't overthink.
Let me see it. Let me see yours.
How was the 5? No.
You're
Am I
right.
right? Am I right? Come on.
Yeah, you are. Azteca. Isn't he wrong, Azteca?
I'm right.
I've got two.
It is because look, that was a -2 over here.
Which one?
Because this is a 5, right?
Yeah.
You're subtracting 5 to 2.
You're not.
Yes, you are.
A minus B.
Azteca. He has a point. I told you.
A minus B, guys.
Azteca.
2y5x over 3.
I was.
I'm tired of this.
Anything that's negative.
Azteca, you made me fail.
Don't overthink it.
No.
I thought I had it.
Now you're not taking
I thought
that.
I had it.
Wait, can you guys tell me what's hard about this? Because I don't get it. Yes.
Some people
Nothing's
think
hard
it's
about
either
it.
A minus B.
They try.
And other
They
people
try to
think
bring the
it's B
negative back
so,
up.
yeah,
So they
so-
have.
See how that
Oh.
They subtracted 2 from 5. No, 5 from 2, which made it 3, and it's negative.
Okay, the thing is, I never liked this rule. Because that's too much memorizing. I like this a lot better. I know you guys think, oh, it's writing too many. You don't have to write it every time if you get the idea. Okay?
Oh, because there's more on the bottom.
Yes,
Top
top
right.
heavy, bottom heavy. Okay. So do you guys see, like this is so easy to get messed up because if you do B minus A, then you have these negatives, and what do you do with these negatives? So this is what I do. 14 over 7 is 2, right? So you have a 2. But look, here there's X and X, and there's 12 Y's. Okay, you don't even have to draw them all out. You just know that there's going to be a lot of them. A lot of them. Okay? And then you have 5 X's. And once you get the idea, you don't even have to do that anymore. But you know there's 5 of them. And how many Y's?
7.
Okay, so the X's are going to battle it out and the Y's are going to battle it out.
Right?
When you start canceling them, how many at most can you cancel? 2. Well, who has more, the top or the bottom? So in the end, who's going to have X's left over? The bottom. How many are they going to have? 3. So there's 3 of them on the bottom. When the Y's battle it out, who has more?
The top.
The top. How many more does the top have? 5 more. So you're going to have 5 on the top. See that? Okay. Does that make sense? All right. Is this all recorded on candid camera? Or not even uncandid camera? Okay. Last rule of the day, I think. Okay. What if you have x to the a to the b power?
I got you.
This time you can multiply the exponents, right?
Yes.
Why?
Oh, because it's in the parentheses. So you have to
That's
add
what parentheses
as
mean.
What does that mean, you mean? You always just say rules, but what does that mean?
But I
Okay.
know what it means.
Okay, if I have x to the 4th
If I know what it
cubed,
means, then
big picture, what's happening?
It's X to the 4th.
Something is being
Well,
Multiply.
cubed.
huh?
Something is being cubed, right? What is being cubed?
X4.
X to the 4.
Okay. That works.
Well, how many x's are in there? 4, and then 4, and then 4. No, but that's better than memorizing rules that you get wrong. So in the end, multiply them together, and when you multiply, they just... How many x's do you have?
You have 3.
4 plus 4 plus 4.
That is 12.
If you want, we could do 1. How many x's do we have?
12.
So do you see why we multiply the exponents?
Why isn't it 12x?
Because that's
I know.
x plus x. Okay, all right. You know what? This is not technically a rule, but let's make it a rule. What if we have x, y, and z to the a power? Okay. So you could do x to the a times y to the a times z to the a, right? How come? And Yumi, don't say because you can distribute the a. Why can I distribute that a?
Because. You can distribute the A.
What does this mean, big picture? Let's expand it out. If I have x, y, and z squared, okay? What is the big picture? What's happening? Something is being squared. What is being squared? X, Y, Z, and X, Y, Z. Okay, let's make it cubed. If it was being cubed, then I need one more, huh? So how many, can I rearrange the order?
Yeah, because it's multiplying.
Yeah, because it's multiplying. So it's x, 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 y, 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 z, z, z. So how many x's do we have?
We have 3.
So is it 3x or x cubed? X
3x.
cubed.
Oh, cubed.
So that's why I can distribute that exponent. You see that? But do not be confused with can I distribute that exponent?
No, because it's a distribution.
We talked about this today. Couch potato. What a couch block.
Solve inside the parentheses first.
Does that equal x to the a plus y to the a plus z to the a?
No.
This is a red flag.
Such a red
Okay?
Such a red flag.
When it's being added, you cannot distribute. Why?
You told us this before. Because.
Let's think about it. You have to expand. That's right. Because if I had x plus y plus z squared, that would be x plus y plus z times x plus y plus z. Can you just say, oh, this is x squared and this is y squared? No, you'd have to go 1, 2, 3, 4, 5, 6, 7, 8, 9. We would have 9 terms. It would be x squared plus xy plus xz plus yx plus y squared plus yz plus zx plus zy plus z squared. They would have 9 terms. There's no way on Earth or Mars that that is the same thing as that. Okay? You see that?
Like now this image is in my head.
Good.
Might as well do it.
Okay?
Yes.
Oh. You're like, I remember seeing her do that one time. Okay. You guys ready to try? Oh, look, it's almost time.
Right way, Miss Holmes. Just leave it alone.
She showed
You just, well, this is the right way. So don't ever do this. This is the right way. But I would never ask you to do that unless I really wanted you to do that.
You know, don't make her do that.
That's the
You don't
right
want
way.
Okay? So don't do, but you just can't do that. Okay? But you know what? If those are simple numbers, then why don't you just add these numbers first and then square it later?
Yeah, that's what I said.
Yeah.
Solve for the parentheses first.
Okay, good.
But you can't.
Let's evaluate, not solve. Okay, now you guys, I'm gonna give you guys some problems. Okay? Imagine this is a test. Imagine?
Just grade 65% right now. Only goals.
Okay, imagine this is a test. Okay? A little pop test. Okay. Alright. I want you guys to keep track, okay? On your board of how many you get right and how many you get wrong. Okay? Can you do that? Okay. I want you to.
This book is annoying.
Oh, job.
Okay, what's the answer?
A little calculus person.
Well, I don't know.
I don't know, some of you are wishing you took notes earlier.
Yeah. We have to go around.
Okay, do those 4 problems.
Then on the book it says this. Same y like this y. The answer is this, but then I got this. But y equals this. You know what I'm saying? See how that book tricked me like that? Like, I was like,
They
where?
put that down?
Yeah, they put like y like y
Oh,
equals.
that's
I was
awesome.
really.
But that's what the AP is gonna do. So you know how you guys complain that the test was too hard? Well, now you should
They
study
say like
this.
dy dx equals this, and then you got to turn it back.
I don't think the AP normally does that. Obviously, honestly,
That was
I think
pretty
this
bad.
is a little, yeah, it's pretty bad.
messed up.
But you should be able to, yeah. Well, if you notice that your answers aren't there,
And if that's why I was like, wait. And then I was like, I looked in the back.
Are we retaking this one? The unit 2 algebra?
no, well, I remember that's the one I, yeah. So yeah, you are, because, well, yeah, it's being replaced by all of these.
Okay.
Yeah.
Then I'll do fine.
Try to do it without talking to your buddy. See if you can figure it out now. What happened to Jiva? Oh yeah, they said they're coming back tomorrow. Oh, Yumi, hurry up! Come on, dude, you guys are distracting him. He needs to pass math.
Oh, my fault.
Let him do it on his own. He needs to.
One out of 20. If it's negative, don't flip the percent.
You mean flip the fraction?
Wait, it doesn't equal 0. Damn, Josh. Yeah, you said it equals 0.
Wait, I'm still writing this chart. I'm writing everything.
Not for the second one, you need to leave.
No, equals 1.
It should be 9. But not have 1 is just not a 1.
So equals 3.
Negative 3.
The last one, you gotta simplify it.
How?
Gotta simplify it a
The
little
second one,
more.
dude, the second one is weird.
You said not suck, you said not suck.
I know. Okay, you have 1 more minute.
16.
When does the next bus come?
5:30.
Number 2.
She really about to let them out at 5:30.
Pretty.
Okay, this is 3. The answer. Oh, this is 2. This 1, 2.
Oh wait, you have to simplify this one more.
The square root of 27 is 3.
The x to the 3 halves equals x to the 1 half?
Yeah. 3 times 3 is 9 times 3 is 27.
No, not this one.
3.
Ace this time. Both of you this time. Both of you this time.
16 over 4.
Yeah, see? So here.
Then I have to simplify this because it is perfect cube. So then,
So then this is saying. Yes.
Persuade, were you able to do every problem in the test questions and understand it?
yep.
Were there any that you just didn't fully get?
Alright, look, you don't even know how to do this, okay? How does it do?
Did you look it up on the
Did AP cancel come out yet?
I don't know. I wasn't in there. I wasn't for those kinds of things.
You have to find the reciprocal.
Eight times 2.
Alright, so you put it one right here, right? And so you're doing it here. So it's 4. You know how to do this, right? Alright, so 6, so it's 2 times 2 times 2 times 2. Because 2 times 2 is 4, 2 times 2 is 4. So
Okay,
so 2 times 4 is 16, right?
here are the answers, guys.
Then 6. So it's 2, right?
It's not yet, I'm not ready.
Then you do 8.
So then this is
Please explain number 2. Please explain number 2.
If I get these answers right, I'm gonna cry right now. Because he doesn't sound. Yes. Let's see, where you? No. I have 3. Okay. You need to do it. It's supposed to be easier.
1
8. 1 8 this time?
Mm-hmm.
That's fine.
Oh, I forgot to. Huh?
What? This is not even cool. I'm gonna stay forever. Yes, I am sad, man.
Literally.
What happened to Gustavo? He ate my chocolate and left.
Isn't this right though? Right here?
chocolate made him happy.
No, that goes in the inside and this goes in the outside.
Okay, you take out 2 axes?
Yeah, because it's square root.
I didn't let the
I need to retake on this practice. For real. I failed this so
Too big to start seeing the classes. This one, this is the morning one. This one is maybe like a morning presentation, not that. No, that means like daytime.
I was wrong, bro.
It's 5 o'clock. Right. You reinstated. Not this Friday.
What did she say? It's like X?
It's lit?
No,
Not,
it's side.
wait, when?
I didn't say that. You didn't have sight.
Close your eyes.
Oh, it's being the same thing as
I didn't you guys know. Why you been telling people?
I didn't bring it up. It was
Okay, guys.
George.
Okay, do you need me to explain any of these?
Yes, no.
Which one? Anybody need me to
No, actually,
explain?
number three.
Number 3, okay. So the negative exponent, I'm going to deal with the negative. Are you listening?
Yes.
I'm going to deal with the negative first. The negative exponent is 1 over, so you put it under 1. So 1 over 16 to the 3/4. But 16 to the 3/4, remember that's 16 cubed times the 4th root of the fourth root. Is it easier to do the 4th root of 16 first or the cube of 16 first? No, 4th root. Because 16 is a perfect 4th exponent, right? What's the 4th root of 16? 2. And what's 2 cubed? 8. Okay?
Switch 3 and 4.
So if number 6, hey. If it says 16 to the positive 3/4, it would have been 8. But because it was negative 3/4, it's 1 over 8. Okay?
Because of the negative.
No, I know. It's like right here, but like, look.
Yeah. No, he just needs to focus.
Um,
Okay? Does everybody see how to do number 4?
Miss Han.
Yeah.
Why doesn't the 3, why don't you, cube
Which one?
1 over, never mind.
Okay. Okay, you guys, I want you to record how many you got right out of those 4. Okay?
1.
Okay, now I'm going to give you guys 4 more. Okay?
Okay, I got you.
All right. Can you do 9 times x cubed times y to the 6 all to the negative 2 power? Can you do x to the negative 3 times x to the positive 3 plus y to the 4 times y to the negative 4?
Oh, that's right. Oh, so you gotta set the bottom to the 0 and you have to find when it's vertical.
Peace and love.
Alright, man.
We just did pack homes from the Thanksgiving country and I just explained
I got an FRQ to do.
Apparently we do. Hey, does Noel have our email?
10.
How are we supposed to send it to him?
This is why you don't get it. You're still not focused.
About governance.
This is not the time. Okay, do them one at a time, okay?
Yeah.
Do you want me to put the... how do I do this? Let's just do the first 2 first, and then I can check your answers on the first 2, okay?
Okay.
I got mine.
Didn't anything.
I think it's alright.
I leave everything in your class.
You too.
How are you, Miss Han?
Good.
Hey, I was really excited that Pedro came.
I know.
And I think he's like interested.
Awesome.
Like,
I know. It was cool.
he was like, "Who's Ben? Like, who's that guy?" And I'm like, "Oh, he like comes to our church." And then he's like, "What do you guys do on Fridays? I heard you guys do stuff." And I'm like,
That's
like,
awesome.
well, you could come, you know, like.
That's awesome.
Thank you.
That's what I meant to say. What the hell, I'm going back to where I was supposed to be?
Right.
Becca, doesn't this go in?
Don't you have to go by pen
This is wrong.
No, you don't.
Hey.
You add it, it's the same rate.
I mean, you got the other one wrong, so like. That was easier.
Oh my god!
Check it.
What do you do with this and this?
Can you do the reciprocal? Like when you go over there? I put it over one and then I know.
He could do it his way too, except you don't have to distribute that negative two.
You guys, am I invited? Am I invited or not?
Oh, I didn't put the negative two. One.
Am I right?
Both you're right. I mean, both methods are right, but he made an error there. You're right.
Negative science now.
Translate negative two. Yeah.
Now.
That's not a problem.
Okay, one is
Hey, that's
negative.
minus 2 on 3.
Okay.
Is the rest right? Is this right?
No.
It's not like this.
And I'm so glad I can.
How's it not right? For what? How's it not right?
It's just that one page.
What?
Was it midterm?
They don't work?
Yeah.
They don't work. I run them for a reason.
It's on one page. We're above the K9.
Oh, yeah.
Almost everything you got wrong.
Oh, I got the whole test already.
You got 1, 2, 3, 4, 5 problems wrong. Okay, I'll go over them with you tomorrow at lunch.
So Miss Han, is this wrong?
Sorry, I hit my butt. I hit my butt.
I'll come in
That's
tomorrow.
why I was like, I don't know, moaning in your.
Yeah, I'll look over it before I talk to you.
Okay. Well, no, I did them on a separate page.
Oh, okay.
True.
Because this is the same base.
Yep.
So this is right too?
But this is wrong.
Okay, you guys, let me go over 5 and 6 with you, okay? Number 5 is this. Okay, number 5 is this. 1 over 81 times x to the 6th, y to the 12th.
Could it like make it negative?
Yeah, you could say 1 over 81 times x to the negative 6. What?
I mean, you got it wrong.
Multiply who?
I mean,
Why? I did. Oh, because you could do that, remember? Your demise, remember? When you have this, you can multiply and you can distribute when it's multiplied.
I got 75%.
That's why you can't just memorize the rules. You have to. Okay, so remember, Fatima. Yeah, you guys, stop talking, please. Fatima, remember, you could do 1 over 9x cubed y to the 6th squared. And remember, you could always expand it. It's 9x cubed y to the 6th. Stop talking. Nobody should be talking except me right now. Okay? And then you would add, it's x to the 6th, y to the 12th.
Just leave it.
Okay?
Monica told me to tell.
Okay, thank you. Wait, 1 second. Okay. 6. Look, you have to add the exponents. Negative 3 plus 3 is 0. 4 minus 4 is 0. So y to the 0 is
0.
X to the 0 is anything to the 0 is 1. So then you get 2. Okay, you could do this first, and it's a to the square. Okay, so it's a to the 6. This is 4x squared times 8y cubed, which is 32. Wait, what did I just do here? Oops, I forgot the y squared. Well, it's negative 3 plus 5.
Wait.
You could have also said it's a to the 5 over a cubed, all of that cubed.
Where'd you get the x squared from?
This? Oh, you're right. You're right. It's not squared.
Just x.
Yeah. These were the questions straight up from your test list this week, right?
Not all 4 right.
Can you take me home again?
You gotta practice. No, it didn't.
Yes, it is. You said they're still outside.
What's up there?
Excuse me.
Did you say?
Yeah.
They're still outside. They're still outside.
Yeah.
Bye, guys.
You can take me home.
In the beginning, this is a